In this video, I'll be going over how to solve quadratic equations. So, as a refresher, a quadratic equation is any equation, for example, where the variable is getting squared. So the general form, well, let me write another example, x squared minus 4. These are both examples of quadratic equations with variables getting squared. The general form, ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers. Okay, so this is an example, or this is the format that a quadratic equation takes. And so there are a few different ways that we can solve a quadratic equation. In this video, we'll be going over 4 of them. We can factor. We can use the square root principle. We can complete the square. Or we can use the quadratic formula. So I'll be going over an example of each of these. So solving a quadratic equation by factoring is usually the preferred method because it's the quickest, but we can't solve all quadratic equations by factoring. So what we want to do, we have x squared plus 8x plus 15 is equal to 0. All we do is, on the left-hand side of this equation, we see, can we factor this trinomial expression? And we can. We want to think, first of all, we have x squared, so in the first two terms of each binomial, we list x, because x times x gives us x squared, and then we think about 15 and 8. The question we ask is what numbers multiply to 15 that also add up to 8, and those two numbers are 5 and 3. So this is the correct factorization. Once we have the quadratic equation factored, we use what's called the zero product principle to set each of these factors equal to 0, and then we solve each equation. So x is equal to -5 and -3. Now let's quickly do a couple more examples. Suppose we have this equation. Now this doesn't look to be quadratic because our highest degree is 3 here. But let's set this equal to 0 and see where we end up. Okay, so what we see is we have a common factor of x in each term. So let's factor that out. That gives us 3x squared plus 5x minus 2 is equal to 0. Now this in here is a quadratic polynomial. So what we can do is we can try to factor that, and that does factor. We get 3x and x, and then we're going to have positive 2, negative 1 like this. And we can always check to see that our factorization is correct by multiplying out and making sure we get what we started with. So this is the correct factorization, but now we have 3 factors equal to 0 that are getting multiplied together that equal 0. So what we do is we set each of those factors equal to 0 and solve each equation. So we get x is equal to 0. This is going to be x is equal to 1/3, and then we get x is equal to -2. So we get 3 solutions there. Okay, and then lastly, let's look at x squared minus 9 is equal to 0. This is in a different form. We only have 2 terms. So when we looked back at the general form, here this term b is going to be equal to 0. That's what we have in this example. So we only have an a term and a c term. Okay, so this expression, or this quadratic equation factors as a difference of squares, x plus 3x minus 3. Okay, and then we just get x is equal to -3, x is equal to positive 3 as our 2 solutions. All right, so here are a few ways that we can factor quadratic equations. Let's next look at how we can use the square root property. So we can use the square root property when we have a quadratic equation in the form x squared or ax squared plus c equal to 0. So in other words, b is equal to 0 here. There's no b term. Okay, that's when we can use the square root property. So for example, suppose we have, let's start with an easier one, x squared minus 9 is equal to 0. Well, this is actually the same one that we saw over here. So we can solve this by using the square root property if we isolate the x squared and then take the square root of both sides. What we get is x is equal to plus or minus 3 here. So we use the plus or minus here because we want all possible values that solve this equation, and both positive 3 and negative 3 solve this equation. Now, we may not always get something as clean as this. Let's say we have 3x squared plus 5 is equal to 0. So we're going to isolate the x squared. So 3x squared is equal to negative 5. X squared is equal to negative 5 thirds. Take the square root of both sides. We're going to get x is equal to, well, we have a negative value under the radical, so that means we're going to end up with an I term. So this is going to be plus or minus I square root of 5 thirds. Those are the solutions. So we have I, which is the imaginary number, and this just means the solutions are not real numbers, they're complex numbers. So that's about as complicated as it will get. We have the square root property, and again, we use that when we just have two terms. We have the quadratic term with x squared, and then we have the constant term. Next, we can use something called completing the square to solve a quadratic equation. So suppose we have x squared minus 3x minus 5 is equal to 0. So this is this is a very procedural way of solving a quadratic equation. So there's kind of some specific steps that we take. So first, what we want to do is get the a term and the b term isolated on the left side of the equation, and then we move the c term to the right side, so we add 5 to both sides. And then what we do is we take the b term, which is negative 3, multiply it by 1/2, and then we square that. So negative 3 times 1/2 is negative 3/2. Negative 3/2 squared is 9/4. So what we do is we add 9/4 to both sides of the equation. Now the reason that we do this is because this allows these three terms to be factored into a perfect square. In other words, when we factor these, we get two binomials that are the exact same. Minus 3/2, minus 3/2. Because ultimately what we want to do when we are completing the square, we want to get something that looks like this form. We have a binomial getting squared. That's what it means to complete the square. Find a binomial that's getting squared. Okay, so on the right hand side I have 5 plus 9/4. Well, 5 is the same as 20/4. So this is 29/4. So what we do is we square root both sides. We end up with x minus 3/2. Square rooting undoes the square. And then square root of 29/4, well, I'm just going to leave square root of 29 in the numerator. The square root of 4 is 2. And then we add, well, before I add 3/2, we want to say that we're taking the plus or minus here. So lastly, kind of going out of order, add 3/2 to both sides, we get x is equal to 3/2 plus or minus square root 29/2. And we can write this as a single fraction, 3 plus or minus square root of 29 all over 2. So this is how we complete the square. Now, I would say, in general, factoring is always the first and best way of solving a quadratic equation. Next, if we can use the square root property, that's what we should do. And then it's up to each individual person whether they would like to complete the square or use the quadratic formula. Typically, one of those two is how each individual person kind of the path that they follow. Personally, I always just use the quadratic formula if the equation cannot be factored, just because I feel most comfortable with it. But some people really like completing the square to solve quadratic equations. So the fourth way that we can solve a quadratic equation is by using the quadratic formula. And the quadratic formula looks like this: x is equal to negative b plus or minus square root b squared minus 4ac all over 2 times a. Now I'm going to derive this formula. So suppose we have a quadratic formula: ax squared plus bx plus c is equal to 0. So what we do is we complete the square for this. So I'm going to subtract c from both sides, and then I'm going to divide each term by a to get x squared as the leading coefficient. So x squared plus b over ax is equal to negative c over a. So remember, what we do is we take this term and we multiply it by 1/2, and then we square that. So what we'd end up with is b over 2a squared, which is b squared over 4a squared. Okay, so that's what gets added right here, and then we add it to the left side. We can't just add a term to one side of the equation. Whatever we do to one side, we need to do to the other side. Now, the whole reason we do that is because this now is going to factor as plus b over 2a, which means x plus b over 2a squared is equal to, well, on the right-hand side, we need to get a common denominator between these two fractions. So what we need is a 4a in the denominator on the left side. So what I'm going to do is I'm going to multiply top and bottom here by 4a over 4a. So we end up with is negative 4ac over 4a squared plus b squared over 4a squared. Combining those two fractions, we end up with b squared minus 4ac all over 4a squared. Okay. Now on the left side, because that's a binomial getting squared, if we take the square root, that will remove the square. So we end up with x plus b over 2a is equal to, well, in the numerator, we end up with b squared minus 4ac, square root of that. In the denominator, the square root of 4a squared, I can write that as 2a. So 2a times 2a gives us 4a squared. So the square root of that is 2a. And we need a plus or minus right here. And then we simply subtract b over 2a from both sides. So what we end up with is x, I'll write that, minus b over 2a, minus b over 2a. So because the denominators are the same, we end up with negative b plus or minus square root b squared minus 4a. Let's see, I'm missing something here. I made a mistake right here. When we add these two numerators together, we get b squared minus 4ac. I wrote 4a squared, so there should be a c here. 4ac, and then 4ac, all over 2 times a. And that is the quadratic formula. That gives us a formula to solve for x when we have a quadratic equation. Okay, so let's do one example showing how this works. Alright, so let's solve this equation. x squared plus 5x plus 1 is equal to 0. Now, the thought process that we should go through is probably to think, can this be factored? So we can check, can this be factored? Well, are there any two numbers that multiply to 1 that add up to 5? Well, the only two numbers I can get that add up to, or multiply to 1 are 1 and 1, or -1 and -1, and those do not add to 1, so we can't factor. We cannot use the square root property because we have a term, we have a b term, okay, so that's not going to work. So we could we could complete the square here, because completing the square always works no matter what our quadratic equation is. We can also use the quadratic formula. So the quadratic formula and completing the square will always work, but we've already done an example where we completed the square, so let's use the quadratic formula. So what we want to do is identify the a value, the b value, and the c value, and then we just plug it into the formula. Okay, so we need to figure out what a, b, and c are. So x is equal to opposite of b, plus or minus square root b squared minus 4ac divided by 2 times a. So you end up with -5 plus or minus the square root. 5 squared is 25, minus 4 times 1 times 1 is 4, divided by 2. And we end up with -5 plus or minus square root. 25 minus 4 is 21, divided by 2. And that gives us our solution.